Hey everyone, and welcome to this short introduction to PyLdB, a free Python-based perceived loudness calculator. My name is Christian Bolander, the creator of PyLdB, and I am currently working with the Utah State University Aero Lab researching supersonic morphing wing optimization. This video will give a short description of PyLdB, its uses, and the motivation behind its creation, as well as an in-depth tutorial on downloading and using its features. Let's jump right into it. Is an open source Python module that allows you to calculate the perceived loudness in PLdB of a pressure signature. Specifically, PyLdB was created to facilitate the calculation of the perceived loudness of sonic booms. Currently, the only other code available to the public for PLdB calculation is the NASA LCASB program. PyLdB gives you an opportunity to implement the same calculation as LCASB, but without the restrictions. Those interested in the theory behind the calculation of perceived loudness can check in the description for more information. Okay, now that we've gone through what PyLdB is and why it was created, let's jump right into how you can access it. PyLdB is currently hosted as an individual project on the USU Aero Lab's GitHub account. I've put a link in the description that will take you there. Once there, simply click the clone or download button and choose whether to save the file as a zip or to clone it directly using Git. There are additional instructions located under the installation section of the README if you need help. Now that we have downloaded PyLdB, we need a pressure signature to use it on. PyLdB is set up to take pressure signatures with time in milliseconds and pressure in pounds per square foot. So make sure that you convert your signature to these units. This is an example signature that I will be using. PyLdB has the ability to read a 2-column text file, like I have here, with time on the left and pressure on the right, in addition to the ability to simply accept time and pressure arrays directly. We will talk a little bit more about that when we get into the implementation of PyLdB next. With PyLdB downloaded and a pressure signature available, we can now calculate perceived loudness. The ease of implementation is one of PyLdB's greatest strengths. We can simply open a new script and import PyLdB. There are two main functions that can be used with PyLdB. They're called perceived loudness and import sig. Let's cover perceived loudness first. Perceived loudness takes as arguments a time and a pressure array, again in units of milliseconds and pounds per square foot respectively. Optional parameters include pad front and pad rear, which are both integer values, and len window, which is also an integer value. Pad front and pad rear can be used to zero pad your signature, and len window controls the length of the handing window applied to the front and rear of the signature. Let's talk briefly about using these optional parameters. Zero padding is a method of increasing the resolution in a signature's fast Fourier transform. Without getting too bogged down in the specifics, zero padding allows you to converge your PLdB value by increasing the integer values of pad front and pad rear. I'd recommend setting these values to 10 to start with. Len window is a very volatile parameter that should be used with caution. Adjusting this parameter changes the actual values of your signature, meaning it can greatly affect your PLdB calculation. I would suggest that you set this integer value to no more than 10% of your total signal length. The benefits of windowing are important in the calculation of PLdB, however, so if you are unsure, the default value is 800 points, and that is appropriate for a signal with 10,000 data points. Great, so we've covered perceived loudness. Now let's move into import sig. This gives us the ability to import a signature. I will use the .sig file that I showed earlier. Import sig takes a file name as an argument, in addition to an optional parameter called header lines that allows you to choose how many lines of header text you have in your file. This signature has 3 lines of header text. So I can simply type pyldb.importsig, give the file name, and set header lines equal to 3. import sig will return a time array and a pressure array from this signature. Using that time and pressure array, we can then call perceived loudness, import the time and pressure array from import sig, set the pad front and the pad rear values equal to 10, and len window equal to 800. Let's go ahead and print out this variable PLdB and see how it works. So as you can see here, this value is the PLdB for the specific signature that we have here. And it's really that easy. Well, thank you very much for watching this brief tutorial on how to use PyLdB. If you have any specific questions about some of these parameters that we talked about, the documentation is in the source code of PyLdB that you can get from GitHub. In addition, if you have any questions for us, feel free to leave a comment in the comment section below.